Dion, you mind closing the blinds? Sorry, you happen to be there. Diane, could you turn off the front lights for us? Thank you very much. So I'm leaving the first page blank so that maybe down the road, when we're closer to the end of the unit, I can kind of just give you a little picture. This is what we've done, right? Boom, boom, boom. And then you have a nice overview. I'm going to skip that for now and dive right in. This is also a shorter unit, so 6 to 7 days. And then, so it's going to be a shorter unit, just giving you a heads up, right? So let's go and introduce the topics. There's a lot of terminology that you need to be familiar with before we can start talking about and solving problems. Okay, so there's something we call the universal set. So I hope you're not going to fall asleep on me. Just make sure you try to like wake up and focus right now, right? I'm going to add lots of little margin notes. So make sure you have a highlighter ready. In fact, this unit, if you have your 4 highlighters, 4 different colors, it would be an asset, especially starting tomorrow. So we have something called the universal set, and that's our most often referred to as the U set, okay? And it refers to all possible elements that could be considered for a certain set. Sometimes we call this, or we refer to the universal set as our sample space. I'm going to give you a very simple example. This class right now could be considered a universal set. So let's say I make a work problem. I say Mr. Dirkson's grade 12 applied class. Then that's referred to as the universal set right now. We always use capital letters to refer to sets or subsets. That's important. And you must use braces to open and close a set. And by braces, we're talking these ones, the squiggly lines like this. Squiggly brackets, that's my term for them, okay? What is a set? A collection of objects that have something in common or follow a particular rule. Elements, the objects in a set are called elements. So if U is the grade 12 applied math class, Mr. Dirksen, then the elements would be the students that are in there. That would be the elements. Note, every element must be unique. You cannot have repeats, right? So elements should not repeat. They should be unique, right? And they have to be arranged. So either alphabetical or numerical. And I'll talk about that in a bit. After a while, you're just going to know that's what I'm supposed to do, okay? Subset, a set within a set. That's what a subset is. All of the objects belong to a greater set. We use the notation, right? We use that notation for subsets, right? So when you see A is subset of B, by the way, that could be a true or false statement, right? We will explore that. But if this is how you read it, A is a subset of B, and what does that mean? That all elements in A can be found in B as well. That's the definition of a subset. In a Venn diagram, subsets are drawn inside a set. And you're like, what? So I'm going to try to give you, oh no, it's coming up, so I'm not going to give you an example. Even if one element, right, this is very important, I'm not going to highlight that, but even if one element in A would not be part of B, then we write A is not a subset of B. And right now you're probably thinking, when is this going to stop? Well, soon I'm going to apply these concepts. First you need to know, right? If you look back, it's like, what is a subset again? So here we have set A. This is set A, and these are the elements in there. We have set B, and it has elements in there as well. Can I just tell you something? Do you notice that they're arranged in alphabetical order? Look at them carefully. I made sure they do. Sometimes I might make a mistake here and there, but technically you're supposed to arrange them. So arranged alphabetical. I don't know. I'm just gonna, okay, just letting you know both sets have been arranged in alphabetical order. Um, and let's draw our first Venn diagram of this course. Okay, so we're gonna say that we always have a box surrounding it, and that represents like the universal set, the sample space you can draw from. Okay. Let's do a check before you do your diagram. Before you do your diagram, see if they have things in common. So blue, you see that both of them have blue? Both sets have blue, right? Both sets have green, you see that? And both sets have red. So you found things in common, and better yet, would you have to agree that all the elements in A are also found in B, correct? All right. So then we can say since all elements in A are also in B, right? We can conclude by saying A is a subset of B. And it's almost like a longer C, right? The C kind of extends a little bit. So we were saying A is a subset of B. But can we say this? Can we say that all elements in B are also found in A? No, right? So then you have to do one of these. All elements in B are not found in A, but the other way around, yes. Okay. So watch what I'm going to do. I'm going to draw a bigger circle that's going to represent set B, and A is going to be inside of it. So you put a little A next to that smaller circle. This is going to be tough for me, guys, because I can't write small, but it's blue, green, red. Okay. Inside that A, I should have made it bigger. That's blue, green, and red. Let me zoom in so you can see that clearly. Okay, blue, green, red. And what would be outside in this one? That's set B. Black and purple would still be outside here. Black, purple. Sorry, I'm making it a little, abbreviating it as best I can, but purple. So that's when you notice that it's a subset. A is a subset of B because it's inside there. Okay. Moving on. I'm gonna do more of those, so I'm not too worried about you not getting it at this point. I think you are. Okay, so when you see the letter N in front of a capital letter like that, it means that it's asking for the number of elements belonging to X is blank. Okay, so let's say you had X's like this: apple, bananas, and the carrots. Yay! Simple words, right? Then you would have to say that N, the number of elements in X is 3. That's as simple as that. Okay. So one is actually stating the elements in there. The other one's asking for the number of elements. So you need to know the difference. Okay. Then there's two different types of, in terms of how many, the number of elements are there. There's something called, when you see dot, dot, dot at the end, that's called an infinite set. Okay. So notice, set D starts with dot, 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 ends with dot, 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 meaning it doesn't matter where you go, it's infinite. It just keeps going indefinitely. So the number of elements in D is infinite. Okay? Then you have your finite sets, right? The number of elements is finite, it's countable, right? Then it's a finite set. I'm making it very obvious that it's countable. So some students think, oh, there's dot, 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 infinite. No, no, no. But notice it starts with a 1 and it ends with a 49. The number of elements in K, how many number of elements are in there? 1 to 49. 49. Thank you. 49 elements are in there. Because the dot, dot, dot is not at the end. It's in between. It's just to make, it should make you see, okay, I know that there's stuff in between. I just don't want to write it all out. So it ends at 49. What about if K had gone like this? This is for the other units already. What if you saw something like that? How many elements are in there? 1 to 49 is 49. So if you include 0, it's 50. You got that? If you include, yeah. Because it's going to come up. It's going to come up where something starts with a 0 goes to 100, and students say 100 numbers. 101. If 0 is included, it's that extra number, okay? Some of you are like, what are you talking about? Just trying to get you ready for what's coming, all right? Empty or null set, the empty set. No elements are in there, therefore it's empty. It's pretty self-explanatory, right? But you need to know that one. The symbol for an empty set is either 0 crossed out or just 2 squiggly brackets with nothing in there, okay? For example, a set of odd numbers that is divisible by 2, right? If you took all the odd numbers and you said, hey, state all the odd numbers that are divisible by 2, there are none. That would be an empty set, right? Like the number of teachers worse than Mr. Dirksen, right? Empty set, right? Like, see. Outlier elements that are, I'm trying to get this, make you stay awake because I know it's a little dry. The first lesson is dry, okay? Elements that are part of the universal set but are not part of any other sets, okay? That is important. Outliers is extremely important to us, okay? They're part of the universal, but not part of any other sets that are mentioned. So let's say we're talking, I'm making a list here. Number of students with a Samsung or Android and iPhone, right? Okay, then we have survey, Android, iPhone, Apple, whatever, right? And then like, wait a minute, could there be someone that has either one of those? There could be someone in here with a flip phone. Raise your hand, numbers. Flip phones are awesome. But anyways, that would be in this case. In this case, those are outliers. Right? I missed my flip phone. It's so simple. I couldn't check the weather. I didn't check my screen all the time. They're just great. All you needed to do is make that phone call, right? Or get a phone call. Okay, equal sets. This one is not as common, but you need to know. So flip to page 3. Two sets are said to be exactly equal if they contain the exact same elements, right? Two sets that contain the exact same elements. So for example, sorry, I tried my best to come up with a good example, but A is a set whose members are the first 4 positive whole numbers. And then you have this other one that just states what's in there. These are the same set. One is just stating it in words, the other one is stating the numbers. What's wrong with this one, by the way? It's not arranged. You notice that? So let's fix that. I did that on purpose. Trust me. Some mistakes I do on purpose. So 1, 2, 3, 4. That's better. Okay? That's how you should state it if at all possible. Since they have the exact same 4 elements, order doesn't matter, right? When you're comparing whether or not 2 sets are the same, the order would not matter. If every single element is the same, then it's the same set. In fact, you could say A is equal to A. You could even go further saying, hey, set B is actually set A as well, right? You could make that statement. Nothing else there. I don't even know why I left a blank there. But again, you're the first class that gets to see this booklet, so I'm still going to fix it for the next round, okay? Disjoint sets. This is important. This is important. Disjoint versus joint sets. So disjoint sets are two or more sets. They have no elements in common. Right? No elements in common. So Android and Apple users, there's going to be most likely a disjoint set if I ask this room. Anybody have an Apple and an Android at the same time? Nobody's willing to admit. Okay. Anyways, but it's most likely going to be disjoint. There's going to be very few students that are going to have both, right? Disjoint sets are also called, watch this, this is going to come back later, mutually exclusive sets, meaning they don't have anything in common. Another fancy word, fancy set of words to say the exact same thing. For example, the set of even numbers and the set of odd numbers are disjoint. No elements can be found in both. So let's do a little diagram here. Our Venn diagram. Let's make this the even, and this is the odd. Right? So what do we have in even? 0, 2, 4, ... And here we have 1, 3, 5. Hey, what about the negatives, Mr. Dirksen? I know we shouldn't forget about the negatives. Right? -2, -4, right? But they're either even or odd. There is not a single number that is even and odd at the same time. Would you agree? Mm-hmm. All right. So that's a classic disjoint set. Okay. All right. If you drew the things that you agree with your parents, things that you agree with and your parents agree with, maybe it's a disjoint set, right? At this age, maybe as you get older, you're going to have more things in common. Joint sets. Oh, actually, I need to make sure we start doing this. At the top of the box, we also put the U, that's our universal set. Okay? And for us, U in this case would be numbers that are part of the integers. You remember integers? What are integers? Or are whole numbers that could be negative or positive. So those are the only numbers we're considering here. That is our universal set. All of the things that I'm mentioning right here are infinite, right? They're an infinite number of even, infinite number of odd, infinite number of integers. Just make sure you understand that. Sometimes they are finite. Most of the examples we do later are finite. Okay? Joint sets. Two or more sets that have at least one element in common are said to be joint. When a Venn diagram has an overlap, right? The Venn diagram would have an overlap. If overlap is visible, it will be an empty set. That is not true. Oops. That is actually up here. This should have gone up here, but I'm going to just cross this off. Cross that off. That is not true. For the other one we just did, if you drew them crossed over, it would have been an empty set. There's nothing in between. Okay. Let's do an example. A set which has students taking APMR4S and taking biology 40S. Right? There could be students taking both. So let's do a little experiment here. So U would be students, Sisler students in grade 12. That's my universal set. That's what I'm drawing from. Sisler students in grade 12. I'm going to make the set A be students in APMR 4S, and B is going to be students in bio 40S. Okay, a lot of you love biology. When you write when you did the survey thing, so you like to learn about nature, human body, and so forth. So we draw our box, make it as big as possible, and that's our U at the top. Okay, and then if I and I just made these numbers up. I don't. This changes every year. Okay, but this would be a joint set. So this would be set A and set B. We defined it. So let's say that there are 60 students only taking applied, 50 students would be taking both applied and bio, and 30 students, let's say, are only taking biology. Okay, so I just want to highlight that this, because of this, right, that overlap, right, is the joint set, if there's something in there. Okay, and you are probably wondering, what is the 60, 50, 30? That's the number of students we're talking about. Okay, we're not naming them, we're just saying there are that many in each set. Okay. Should I do that already? No, I will wait till later. I have a little added note here, but I think as I work through the booklet, it comes back later. Complement. This is important as well, very important. Complement. Every set or subset has a complement, right? It is denoted by using a tick like that or a dash above the letter. So if you consider, pay close attention to this one. If my universal set is 1, 2, 3, 4, 5, 6, I made it very simple. If E is 2, 4, 6, then E naught, right? Elements that are not an E would be 1, 3, 5, which is, could you say that it's even and odd in a sense? Yeah, you could. It just happened to work out that way, right? So I need you to understand that. In fact, here, watch this. The boxed in is always important. The number of elements in a set plus the number of elements that are not in the set always adds up to your universal, the number of elements in the universal, right? Because look, elements in the set and not in the set, and if you combine these, you get your universal, right? So n of E is equal to 3, n of E naught is equal to 3 as well, right? So we go 3 plus 3 is equal to 6, which is what we wanted, right? It's always going to be the case. Therefore, from this, guys, from this fact here, we can make up these two like we just manipulate to get these two. Okay. So from this, we can deduct. So watch this. We just isolated this expression right here, and then it's universal minus this one that came over here, right? And so forth. So I'm just rewriting it. Let's do a Venn diagram of what we just did here. Notice that the only set being talked about here is set E. We don't create a set that is called not E. That's not what we do. This is the set. This is our universal. We have 6 elements in the universal. And in E, we have 2, 4, and 6. E naught, therefore, is out here. 1, 3, 5. You don't have to have commas in between if you don't want to. but these would be all the elements that are not in E, right? These out here. And why is U is equal to 6? Because it's the number of elements, right? That's all I'm doing there. Okay. Let's keep going. So I just try to stay with me, okay? All right, so this is where we start diving a little deeper here. So next page, we have sets can be expressed in 3 ways. Okay, we can have words describing the elements in it. We can have the elements actually listed, or my favorite, and it's soon to be your favorite, a Venn diagram, or your money back. Wait a minute, you didn't pay for the course. Anyways, let's assume there's a small class of 10 students, just to make it very short and sweet, okay? And so this is in words saying what the set is. Then I go one step further and I give you more detail. I actually name the 10 students, okay? I name it. I call it A. And you're like, Mr. Dirksen, didn't you always tell us that the universal set is going to be called U? I told you that, right? It doesn't really matter, right? It doesn't really matter. In general, that's what we tend to do. But if the question gives you a different letter for that universal set that you're going to grab from, then you go with that letter, okay? So it's still the universal, right? It's still universal set, right? Universal set. Let's call set G students in grade 12 applied wearing glasses. So that's just saying, that's describing the set. Then I go one step further and I say, hey, these are the actual students these are drawn from the universal, right? From that universal, there are 5 students that are wearing glasses. And B is the set of students that have blue eyes. There's no Chip, Jenna, and Xenia in here, so we're good, right? So Chip, Jenna, and Xenia. So these are our 2 sets that we're comparing, right? And I'm kind of going from describing to actually, but these are the ones that you want to focus on, right? Where they actually state what's in there. So let's draw a corresponding Venn diagram. Before you draw your Venn diagram, guys, check if there are common elements. Do the sets that I'm about to draw have something in common? That's the first thing you want to scan for. And do they? Yeah. They do. Okay. I'm going to use green here, but I see that Chip is in both. I see that Jenna is in both sets, right? So what do we call these sets when they share things in common? They're joint. Okay? So make a note, joint sets. I'm going to make that note right off the bat because that's going to tell me, I'm going to draw my Venn diagram and I'm going to make sure that they have an overlap. Why? Because both sets, set G and set B, have something in common. And let's put them in there right away. Chip and Jenna. Okay. On the outside here, we call this set A. Okay. And we'll just leave it like that for now. So now you need to fill in. Yeah. What if you want to do that? Just go up here and just cross that off and call that U. And from there on in, I'm okay. Yeah, from there on. The only thing is you gotta watch out if I further down ask you, is B a subset of A? And you're gonna be like U, A, U. I don't know. Just make sure you don't get confused by that. So Chip and Jenna's there. So I'm gonna go to G. So what have I not used yet, right? So you got to go Biff. You love those names, don't you? Damien and Fernando. Okay. So when you look at G though, just focus on the circle for G. You have 1, 2, 3, 4, 5 elements in there, and there are 5 elements in there, so check. I did that right. Then you go over to set B. Chip and Jenna are already part of it, see? So all you need to add here is Xenia or Xenia, right? So you've got it all. I'm done, Mr. Dirksen. Next. Are you done? What am I missing? 4 people? Because yeah, 1, 2, 3, 4, 5, 6. There are 10 in the universal set. Where do those go? Yeah, they don't get a circle, right? They don't get a circle. What do we call them when they're outside? Outliers. They're lying outside. Okay, so you go back, and now I need to think though. This is so I see that Anna is not, right? Biff has been in there, Chip has been Damien, Dimitri is out, Gurjot, Joel has not been used, right? Joel. Okay. I'm just going to say that these are outliers. And here's where I'm going to start doing something that the textbook does, and I like you doing that. Okay. I start telling myself how many elements are there. 10 in total. How many elements in B? Just one, Mr. Dirksen. Nope. 1, 2, 3. Okay. How many elements in G? 5, right? 5. Right? And so you start telling yourself how many elements are in there. Can I just give you one caution? It's going to be in the homework. When there are a bunch of numbers in here, it's just the actual element being listed. Okay. So some students mix that up with the number of elements that shows up here. So let's say there would be 5 numbers in here, then yeah, there are 5 elements in there. So don't mix that up. It should be pretty straightforward, but some students find that confusing. Okay, let's keep going. So far, so good, I think. Okay, true or false, and then explain. And I apologize, this line bled down here. So we're gonna cross this B out here and just make it appear up here. Can you do that? I just don't like it. So use proper notation to state the complement of G and B. Right, true or false? Is G a subset of A? Some of you are like, yeah. G, what is A again? It's the universal. That's where I grab all my names from. So absolutely G, not J. True, right? True, right? All elements in G are in A. Okay? It's the universal. It better be. You cannot think outside the box when it comes to this one. All right? Contrary to everything we tell you, here the box is it, right? And so there you go. Is B a subset of A? True. And why? Same thing as before. Right? B is part of the universal. Is G a subset of B? No. That's false. But you need to know why. Okay? Not all elements. Look at up there. Just look at G and B, right? You can clearly tell that they only have 2 in common. They don't have everything in common, right? Not all elements in G are in B. Okay. Is B a subset of G? So quiet. I like to go up here, right? B of G, not all of elements, right? Xenia is not in here, so boom, it fails. You have to have every single one in common. So false. Not all elements in B are in G. Okay. So I used up a lot of space there. I'm going to cut this. Watch how I'm doing this. Cut it like that so that we can answer C. Use proper notation to state the complement of G and B. So watch what I'm going to do here. G, the complement of G, I can go bar like that, or I can go a little tick like that. I'm going to purposely go one or the other. I'm going to mix that up. When it says that, it's asking you to actually state the elements that are not in G, and that's where your Venn diagram is going to be nice to have. So follow me. My thumb is perfect for this because it covers everything. If I don't want what's in G, then I gotta go like this. I gotta cover up G, and then I'm left with everything else. That is what not G is. And I have to do that in alphabetical. So Anna, I will usually be pretty good with giving you names that are easy to arrange. Dimitri, I'll just shorten them a little bit. Gurjot, Joel, and Xenia, or Xenia. Okay, so that's not G. Got it? What are the number of elements in not G? 1, 2, 3, 4, 5, right? But this is how I want you to start thinking. I want you to remember that formula that I gave you a page ago? You take your universal and you subtract what is in G. That's how I want you to start thinking. Every time I ask you for the complement, like the number of elements, I want you to start, oh, how many are in the universal? I will take away what is in G, and then I get the number of elements not in G. So my universal is 10. And if you look up here on the Venn diagram, I know that there's 5 elements in G, so that's 5. Okay. So next we're going to go B naught. That's another way of, that's the complement. You cover up everything that's in B. Watch my thumb, right? Or I'm just going to use a marker in this case. Cover everything that is in B, and then you're left with everything that is not in B. So again, Anna, this is going to be a problem. I see that already. Biff, Damien, Dimitri, Fernando, Gurjot, did I miss one? I think I'm good. Joel. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I've got 7. I'm fairly confident that that's right. The number of elements that are not in B, you just told us 7, Mr. Dirksen. No, I'm going to go universal minus, how many are in B according to my Venn diagram? 3. And there's a reason why I'm doing this. I'm not just wanting you to do extra work. It's going to be a lot faster if you do that. Universal minus, right? Boom, you're right there. Okay. Answer the following. I tried my best to build the case before I dive into the word problems, all right? I need you to understand the basics, and then word problems will be like, I got it. Yeah, I know what you're talking about, right? On a smaller scale. Answer the following real quick. When there's an n, it's asking for the number of elements. Remember that. Number of elements in U, 10. Number of elements in G, 5. 3. This one I already did, right? Not G is up here. The 5 that I did. Not B I already did. That's 7. So that's all done real quick. Are sets B and G joint or disjoint? How do you know? I already told you that it's joint. Joint. How do we know? They share 2 elements. That's it. That is why. You could also say, I see that the Venn diagram overlaps. However, the Venn diagram was not given. You drew it. If it's drawn, like if that's all I give you, you're like, yep, I see the overlap. There's elements in there, so they share elements. Boom, right? So just be careful how you answer that. In each case, state whether it's a finite or infinite set. State the number of elements. 258. What is that? It's a finite. Yeah, finite. Because it ends, right? The number of elements is to be pretty straightforward. I don't know what I was thinking when I made this example, but hey, it can't hurt to repeat things, right? So stating the elements, telling me whether or not it's finite. When there's an n in front of that set, I'm asking how many are in there, okay? 2, 4, 6, 8, right? Let E be the set of even positive numbers. 2, 4, 6, 8, dot, 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 so that's infinite. The reason being is that, right? And so you just go infinite. All right, the number of students that like this lesson, what set would that be? That would be an empty set. Anyways, keep going. Anyways, here we go. I need you to know the deck of cards is coming back for probability. And I always assume students know their deck of cards, but then I realized I don't even really know my deck of cards. So I was like, hey, let's come up with this diagram here. So you ready? A deck of cards, you can't see it. I wish I could do this in color, but there's your reds and your black cards, right? So I'm just going to give you a quick run through. So 26 red cards, and there are 26 black cards. So how many are in a set? 52. Right? 52 cards in total. That's a standard deck. No joker, okay? That's just a standard deck without jokers in there. Every single, what do we call each one of these rows? We call them rows. No, but in a deck of cards, there are 4, what do we call those? Suits. There are 4 suits in a deck of cards, right? So you've got every suit has ace to 10, right? So I started the wrong way. Ace to 10. And then there's a jack, there's a queen, and there's a king. Okay? And that's diamonds. So let's repeat that. Ace to 10, jack, queen, king, and that is hearts. Hearts, sorry. A to 10, just write this down real quick. It's going to help you, trust me. I always make spades and clubs, so I think this is spades. And then ace to 10, jack, queen, king of clubs. Okay. So how many kings are there in a set? 1, 2, 3, 4, right? How many red kings? 2, right? The jack, queen, and king We call those face cards. Have you heard of that term? There's an actual, and how many are there? 3 times 4? There are 12 face cards in a deck of cards. And then of everything, there are 4 aces, 4 twos, 4 threes, 4 fours, 4 of everything, right? Of every number and so forth. So I hope this helps, but you need to know that for probability later on, and also from time to time here it will show up. Okay, so I just thought I would do that. Okay, let U in this case be all cards in a standard deck of cards. That's our universal set. R is the red, B is the black cards, H is the elements of all hearts in a deck of cards, D is the diamonds, C is the clubs, S is the spades. Use proper notation to express the set H. Proper notation. So how am I going to do this here? I will just do this. Ace, 1, 2, 3, 4. I can do this. 10, Jack, Queen, King. So that's, you're allowed to do the dot, dot, dot when the pattern has been established, right? You've established that it's going up by 1, and then you're stopping at Jack, Queen, King. And so this is proper notation using the squiggly brackets. The number of elements in the black cards would be 26. There'd be 26 reds. How many hearts? We didn't talk about that, did we? There are 13 in each suit. Can I go up real quick? Sorry. 13, 13, 13, and 13, adding up to 52, right? So there are 13 cards in each suit. So we have 13 hearts, 13 spades, and so forth. True or false? Explain. Let's say you have 4 marks right now. I'm seeing you. This is tomorrow morning, right? If I asked you, is the set H a subset of set B? Are the hearts part of the black card set? Hearts are red, right? Think of your like blood, heart, I don't know, whatever, to help you remember they're reds. So the answer is no, it's false, right? All hearts are red. That's one way of doing it. Or you can say there is no heart card in the black set, right? There's not a single element in there, so that's false. Are the spades a subset of the black cards? Right? You've got 26 black cards. 13 of those are spades, so this is true, right? All spades are also in the black set. Okay? That's the requirement, that every single element in the first one needs to be in the second one. Are the clubs part of the diamonds? False. No club is also a diamond. Are the diamonds a subset of the red? True. All diamonds. You can also say all elements in the diamond set are also part of the red set. Okay? Yikes, right? When is this over? Sorry, I don't write the name of each card. So there's a typo there. Come on, autocorrect. You should have caught that one. So how would you do a Venn diagram of this? Well, you need to start with your box. Actually, I would say don't start with your box in the future because sometimes you need bigger circles, but make sure there's a box around it at some point, right? So if you had your universal, this is my deck of cards. You have two sets that are, it's going to be red and black. Do they have anything in common? Would they be joint or disjoint? It would be disjoint. There's no single red that is also black. So I'm just going to give you a little crash course into this. So reds and blacks. Inside the reds, I have what? Hearts and diamonds. They're also disjoint. Like even if you just zoom into the hearts and diamonds, those are also disjoint. And then on the black side, you have clubs and spades. That would be, if I ever asked you to do that, let's do this real quick. 26, 26, 13, 13, 13, 13. I can tell you're already loving this unit. Okay, that's good. That's good. I can feel the energy. And now that song is just in your mind, right? Energy. Anyways, let's go over to page 6. We're doing good. My plan is to end on page 7. So that's that. Okay. So now we're going to do a little bit more. I think it's going to be, the example is straightforward, but I'm just going to focus in on the little details. Okay. So let U be the set of digits from 1 to 15 inclusive. O the set of odd numbers. T the set of multiples of 3. You know what multiples would be of any number, right? You start with that number and then you go up by that number. Does that make sense? So if multiples of 10, then it's 10, 20, 30. I think you get the point. State all sets using proper notation. So let's go ahead and do that. I will use this space here because there's more room there. So my U, when it says using proper notation, 1, 2, 3, 4, I will list them all. And what does it mean inclusive? 1 to 15 inclusive? That you're including 1 and 15. If this question had said, let U be the set of digits between 1 and 15, you cannot use 1 and 15. It's between. So you'd have to go 2 all the way to 14. Okay? Let O be the set of odd numbers. So from, I have to draw from the universal. So it's 1, 3, 5, 7, 9, 11, 13, 15. Hopefully you know your odd numbers. Of course you do. You made it this far. T is the set of that it contains all the multiples of 3 from the universal. So I got to go to universal. It'll be 3, 6, 9, 12, 15. Okay. So remember, the universal doesn't get a circle. It's the box. Okay. State the complement of each set. The complement of each set. So let's go ahead and do that. So between O and T, so we're going to go O naught. And you got to be smart about this to save time. You obviously notice that it's all the odd numbers, correct? So not O would then be all the things in the universal that are not odd, obviously even, right? So let's go ahead and 2, 4, 6, 8, 10, 12, 14. That's it. T naught, all elements that are not in T. So here you have to be a little bit careful. Watch what I'm going to do. I'm going to go maybe just do one of these. And then I'm just going to highlight them in my universal. 3, 6, 9, 12, 15. So now I've identified in the universal all the ones that are in T. So whatever is left is not T, correct? 1, 2, 4, 5, 7, 8, 10, 11, 13, 14. I hope you're writing this down. Okay. So that is not T. They're not asking for the number of elements. They're actually saying state the set. Okay, so that's what you're supposed to do. Okay, state the number of elements in each of the subsets. N of O, we can just go count, right? 2, 4, 6, 8. N of T, there are 6 in there. And I do that for a reason. I do those two first because I'm going to go right next to it. Watch this, guys. N of O naught. I'm just going to go, what's my universal again? 15, right? There are 15 numbers from 1 to 15. So you can see that there. 1 to 15 is 15. I'm going to subtract 8 from it. Okay, so I'm left with 7. And in this unit, you should be able to double check your values, right? Because if you count up here, 2, 4, 6, 7, right? That matches. Number of elements that are not in T. Again, you take your universal, subtract the elements that are in there, and you're left with 9. I'm going to quickly double check. 2, 4, 6. Wait. Did I make a mistake? 2, 4. There should be 10. What did I do? Oh, oops, the number of elements in T, if you count, is 5. That's the mistake. And that's exactly what I want you to do, okay? Double check. There are ways of checking your answer. So that should be 10. All right. So the numbers are not going to be overwhelming in this unit. They're going to be like, you can do it in your head. It's just like, are you getting them right? Okay, are you picking the right numbers? Are sets O and T joint or disjoint? What would you say? Joint. And this is why. I'm going to go, they have things in common, at least one in common. They can actually stop there, but I'm going to keep going, right? They have 3 elements in common. So they're joint, comma, since they share at least one element. That's why. Okay, specifically, they share 3, 9, and 15. Okay. In particular, that's the one they share. Draw a Venn diagram. So I'm going to go like this. Left you lots of room. Like this. I'm going to put in the ones they share right off the bat. 3, 9, 15. I'm going to go set O on the left, set T on the right. I'm going to box that in. That's my universal, and I know I have 15 elements in there. There are 8 elements in O. There are 5 elements in T. And let the fun begin, right? So let me see if I can zoom out enough so that I would like everything to be on there if possible. Okay, so for O, 3, 9, 15 is already taken. So I just need to put the rest in. 1, 5, 7, 11, 13. I'm gonna avoid the commas. I don't know. I like them just freelancing, floating every which way. Then I go to T. Oh, double check. Let's see. There's supposed to be 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? If you follow this circle, there should be 8 elements in there. I told myself that. In this one, I should have 5. And really, all that is left is 6 and 12. I haven't put them anywhere yet. So 1, 2, 3, 4, 5. And then you check. If I count these 8, right, plus the 2, I've already used 10, right? You agree with me? So I need to make sure the rest are somewhere outside, right? Inside the box, of course. So I'm going to go, how should we do this? What would be the easiest way to do so? I'm just going to look at my Venn diagram as I've used 1, I've used 2 is still to be used, so I'm going to add 2 here. So now that's done. 3 it shows up on my Venn. 4 not there yet, so I'm going to put 4 there. 5 is used. 6 is used. 7 is also 8. Seems like it's the even numbers, right? 9 is already there. 10, 11 is already used. 12, I've already used it. 13, yep. 14 isn't yet, so that's the one I need to add. So now, if you add it up, 10 plus 11, 12, 13, 14, 15, now you have 15 values, right? So whenever you add every section up in this diagram, it should always add up to your universal. Don't miss that, okay? Can I just do this? What are we time-wise? Oh, okay. I will first do F, and then I might go back to do that part. Create a subset, guys. This is a free mark if you know what a subset is. Create a subset of O and T. You can call them P and Q respectively. So P, how do you create a subset of something? You just, yeah, whatever elements you pick, make sure they are in that original you're grabbing from. So I'm going to go to set O here, just up in the Venn diagram, and I'm going to pick random ones, 5 and 15. You're like, 15 is part of T, Mr. Dirksen. Well, yes, but it's also part of O. Okay, that's it. Or you can be fancier if you'd like, and you can go 1, 5, 7, 11, right? You can add more if you want, but any amount that you grab from the original is a subset. Mr. Dirksen, would this be okay if I just did this? Would this be a subset? Would just 9 be a subset of O? It's part of O, isn't it? And there's something in there, so yeah. So look at, let me go even further up. You just look at O, and when you create a new one, grab as many as you want, but don't grab all of them, because then you're creating the exact same. It's not a subset, right? So even if it's 1 less, it's a subset. If it's 2 less, if it's 3 less, right? Did I arrange them? Oh, I didn't. So, oh yeah, I did. Never mind. Yeah, we're good. Good. Okay, what about Q? A subset of, that's my subset of T, right? So you go to T, all of T here, right? That circle, and just grab random ones. 6 could be it, or Q could be 3 and 6, and the list goes on and on. So those are subsets. Make sure that you just grab from the one you're creating, right? So then you're creating a subset there. I think we're gonna leave it there for today. I really want you to do the homework to get you need to think this through, okay? So just to clarify the homework, it's on page 154, that's section 3.1. If you want more, right, page 8 in the workbook. So it's right next to this. It's good, and the key is right next to it. Yeah. This is textbook, yeah. Textbook. And this is workbook. It's right next door. Just flip over, and the key is right next to it, so you don't even need me to post an answer key, right? Thank you, guys.